This lesson, we are going to work on projection of vector u on v. Our goal is to show the relationship between projection of u and v and vector u and vector v. We know if size of a vector is 1, it is called a unit vector. Size of u is 1, u is a unit vector. If vector u is given, there are two vectors with the size of 1 parallel to u. One in direction of u and the other one in opposite direction of u. We use u hat to show the vector is a unit vector. U hat is a unit vector parallel to u. Similarly, minus u hat is a unit vector parallel to u. U hat and u are in the same direction, minus u hat and u are in the opposite direction. Let's see what is the relationship between u and u hat. We know u is a scalar product of u hat. Therefore, u hat can be written as k times u. Therefore, magnitude of u hat and magnitude of ku are the same. Magnitude of m times u is absolute value of m times magnitude of u. Therefore, 1 is magnitude of k times magnitude of u times absolute value of k. This means absolute value of k is 1 over magnitude of u, or k is either plus or minus 1 over magnitude of u. Therefore, u hat in direction of u is 1 over magnitude of u times u. U hat in opposite direction of u is negative 1 over magnitude of u times u. Let's see the relationship between vector v and u if size of v is known and it is parallel to u. We know v is m times u hat because size of v is m. Therefore, v can be written as m times size of u times u hat. Notice that we used u because v is a vector in direction of u. In this diagram, vector p is called projection of vector u on vector v, and it's denoted by p equals projection of u on v. We are looking for relationship between p, u, and v. We know u dot v is size of u, size of v, cosine of theta. Therefore, cosine of theta can be written as u dot v over size of u, size of v. In triangle OAB, cosine of theta is OA divided by OB. Therefore, OA is OB times cosine of theta. Other words, magnitude of P, OA, is magnitude of U, OB times cosine of theta. Cosine of theta is U dot V over size of U, size of V. Therefore, magnitude of projection of U on V is U dot V over size of V. This means vector P is magnitude of P times V hat, a unit vector parallel to V. And V hat is 1 over size of V times V. Therefore, vector P is a scalar product of vector V, and the relationship is P equals U dot V over size of V to the power of 2 times V. Let's have an example. Magnitude of U is 5, magnitude of V, vector V is 4, and angle between the two vectors U and V is 40 degrees. Draw vector P, projection of U and V, and find the magnitude of vector P. Vector U is U is a vector with magnitude of 5, V is a vector with the magnitude of 4, and the angle between them is 40 degrees. P in this diagram is projection of U on V. Magnitude of P is magnitude of U times cosine of 40 degrees. Thanks for watching.